Metals comprise more than 78% of all known elements and appear on the left side of the periodic table. However, the absolute radius of an atom is difficult to measure because it is not possible to isolate an atom from other atom. Electron cloud means where the nucleus having the effective nuclear charge towards the or end up with the last electron, we'll call it as electron cloud. Hello everyone, this is Harshita Bhavsar from Vidhyaashram PU College, Temple of Excellence. Today we are discussing about the classification of elements and periodicity in properties, that is session 2. Okay. In the last class, we have discussed about genesis of periodic classification, modern periodic law and the present form of periodic table, electronic configuration of modern periodic table, classification of the periodic table into blocks. These are the contents which we were discussed in the last session. But today's session, we will discuss the nomenclature of elements above atomic number 100, metals, non-metals and metalloids, periodic trends in properties of elements. In that, we will discuss today atomic radius. Okay. Today, first we will see nomenclature of elements, that is atomic number above 100. First, we have to understand that how this nomenclature have been started. In the so many years back, the naming of new elements was given to the privilege of the discoverers and it was ratified by the IPUC. Okay. But after so many years, in the recent years, which was led to the controversy. After that, why it has been controversy had been started means the new element, whatever the atomic number above 100 was completely unstable. Okay. And after the characterization, they were getting in a minute particle. So, again they have to synthesize that element and characterization should be taken again. But it is not an easy task to do again and again those experiments because it requires very much well equipments and it was very much expensive and they need sophisticated laboratories too. Okay. And moreover, before the discoverers getting the absolute data of that element, they were claiming for their discovery. Okay. For example, the atomic number 104, the Soviet scientist told or gave the name like Kurchatovium, but the American scientist gave the name Rutherfordium. Okay. For these reasons, what the government or the IUPAC have recognized that after the discovery have proven only the official name should be introduced. Till that the nomenclature, whatever they have given, that only should be introduced. By this controversy, by these results, the nomenclature of elements have been started. Okay. We'll see the roots are put together in order of digits which make up the atomic number and EM added to the end. Whatever the nomenclature we will give to the element, at the end, the root of the word should be ended with EM. Okay. This is the notation for IUPAC nomenclature of elements. If we take, we'll see one example, the atomic number 101. Okay. These are the nomenclature words where if digit is 0, we have to name it nil and the abbreviation is N. When the digit is 1, we have to name it UNU. Like that, we are keep on seeing till 9. We'll see example of atomic number 101. For 1, what is there? UN. For 0, NIL, that is nil. Again 1, what is the root word? EM. For 101, the nomenclature name was Unilium. Okay. Like this, we have to write or we have to specify with that atomic number. If we take 105, same thing for 1, 0, nil, for 5, pent, next. Like this, we have to give the notation for the elements with the atomic number above 100. Okay. See, this is more than 101 to till 118. Okay. See here, 101 un nil unium, what we have seen in the last slide. And see here, for symbol U from un, N from nil, again U from un, like that 3 lettered symbol we have written here. Okay. If you see for 107, un from U, N from nil, S from sept, again EM. Okay. Everywhere 3 lettered symbol is present. Then what is this means? They have given IUPAC official name. Okay. See here 104, they have named officially, that is Rutherfordium. After giving that official name, again they will symbolize with IUPAC, that is RF. If you see 110, see here Dermastadium, again the IUPAC symbol DS. Like this till 111 they have named, yet they have to get the official names after 112 atomic number element. Okay, these are the official names, these are the nomenclature, IUPAC nomenclature they have noted like this. Okay, next we will come to the concept metals, non-metals and metalloids. Metals comprise more than 78% of all known elements and appear on the left side of the periodic table. In the whole periodic table, around 70 to 78% will comprise only metals, where it will be present in the left side of the periodic table. Okay. Non-metals are located at the right hand side of the periodic table. At the right hand side, the non-metals will be present. And what are metalloids or semi-metals? It will act as both metallic character and non-metallic character. It will be having both metallic character and non-metallic characters. Metalloids or semi-metals constitute some borderline elements like silicon, germanium, arsenic, antimony and tellurium, etc. They will show both metallic and non-metallic characters. That's why they will tell semi-metals or metalloids. Okay. You know the metallic characters, hard in nature and good conductors of heat and electricity, everything you know. And non-metals, reversible to opposite to metallic characters. These metalloids means both the characters it will be holding of metals and non-metals. We'll see in the periodic table. See the first point, metals are comprised of 78% in the periodic table. The whatever blue colored is there, that will represents the metals. Okay. And see here green color including the hydrogen. What the next second point we have seen, the right side of the periodic table will constitute the non-metals. This is only right side of the periodic table which constitute non-metals. And in between zigzag mannered semi-metals are present, that is silicon, germanium, astatine, tellurium, everything here till astatine we are seen here. Okay. These are the semi-metals or metalloids which will constitute a borderline between them. Okay. The F block also will belongs to metals characters only. This is about metals, non-metals and metalloids. Next, we'll see the periodic trends in properties of elements. Okay. There are certain physical and chemical properties of elements which repeat at certain regular intervals when elements are arranged in the increasing order of their atomic numbers. What they are telling means, in a certain intervals, means in a periodic table, we'll see from left to right or top to bottom, we'll have some certain interval, again the properties will be same. If you see, at the one group, if we consider, the group will contains all the same or similar properties. Before coming from first element to the second element, some interval gap will be present. That only they are telling. There are certain physical and chemical properties of elements which repeat at their certain regular intervals, which will repeat the characters but having the regular intervals arranged in the increasing order of atomic numbers. How the periodic table has been arranged, they are telling like this. These properties are called periodic properties. Okay. These properties show a gradual change along a period or a down the group. How the changes will be seen? Along the period or down the group. Along the period means like this, from left to right. Down the group means from top to bottom. The important periodic properties are in the physical properties like atomic size, ionization potential, electron affinity and electronegativity. Okay, these are the physical properties which can be seen in the periodic table. Next, chemical properties like valency or oxidation states, anomalous properties of second period elements, diagonal relationship and chemical reactivity. These are the chemical properties. You can see about chemical properties and some of the physical properties you will be seen in next session. Okay. First we will see the atomic radius. What is the atomic radius means? It is the distance between the center of nucleus and the outermost shell of the electrons is known as atomic radius. See here. This is the nucleus. This is the outermost electron here present. Okay. The distance between the nucleus and the outermost electron present in the outermost shell, we will call it as atomic radius. But what will happen? In a molecule, some atoms will be very small and it will be attached to one another. So that time we cannot take we cannot express the atomic size. That time we will be expressed in covalent radius, van der Waals radius and metallic radius. That only they are telling. However, the absolute radius of an atom is difficult to measure because it is not possible to isolate an atom from other atom. Sometimes it will be in a combined form. That time we cannot be isolate or separate from one another. That time it is more difficult to take an atomic radius. An atom does not have an exact boundary because electron probability extends to a large distance. Hence, atomic radius is expressed in terms of covalent radius, van der Waals radius and metallic radius. Okay. See this. This is the covalent radius. See, this is the atomic radius. The distance between, whole the distance they are taking. It is already the combined form. Okay. First we have to isolate this one and we have to take the nucleus. For this reason only they have expressed in the terms of covalent radius, van der Waals radius and metallic radius. First we will see the covalent radius. It is 1/2 of the distance between the nuclei of two covalently bonded atoms of the same element, that is homoatomic molecule in a molecule. Okay. They are telling 1/2 of the distance between the nuclei of two covalently bonded, means the bond should be in a covalent nature. Okay. Covalent nature means the sharing of electrons will be happen. So that kind of bond should be there to take this distance with homoatomic molecule. The same molecule from the same element, Cl2, H2, O2, N2, like that in a molecule. The homoatomic means same atom in a element. If you see here, the formula of the covalent radius means internuclear distance in the bonded atom by 2. How they will getting means, see these two atoms, they are covalently bonded. Okay. Here the nucleus, here is also nucleus of the each element. Okay. From here to here one distance, here to here one distance. What they have done? 1/2 of the distance. Overall distance is there, but half distance we have taken and we have given. This is both are hydrogen atoms. Overall 74 picometer we will get from 1/2 another half. The internuclear distance by 2. If you make 74 by 2, we will get 37 picometer. That is the covalent radius. Okay. Another example is here. The bond distance in the chlorine, that is Cl2, is 198 picometer and half of this is 99 picometer. If we do 198 by 2, we will get 99. Means 1/2 of the distance between the two nuclei of covalently bonded of same atom, of same element. Okay. Then we can express or we can find the covalent radius. Next, metallic radius. It is half of the distance between the two nuclei of adjacent metal ions present in a group. The important electron affinity and the metal. What they are telling, it is also a half distance between two nuclei of adjacent metal. Adjacent means one beside the another. that we will call it as adjacent. See here, both are metal atoms and they have adjacent in each other. They have taken the overall radius and they are made up of 2 divided by 2. Same thing what we have done with covalent radius, same thing they are doing here. But their covalently bonded nature, here adjacent of metallic atoms. Same thing they are doing here. Both the metallic atoms which will be divided by 2 will get the metallic radius. For example, the distance between 2 adjacent copper atoms in solid copper is 256 picometer. Divided by 2, 256 divided by 2 is 128. Here, to be adjacent, what is the important character of the atom is, it should be having the electron affinity property and the atom should be a metal atom. That time only we can see the metallic radius. Next, van der Waals radius. It is 1/2 of the distance between the nuclei of 2 adjacent identical atoms of neighboring molecules. Molecules only neighboringly present molecules. Between that 2 adjacent identical nuclei we have to found. That time we have to see the 1/2 of the distance. See here, this is molecule 1, this is molecule 2. In this molecule 1, 2 adjacent molecules are present, that is same kind of molecule. Here also molecule 2, same kind of molecule. But both are neighboring to each other. At that time, we have to take distance and within that distance, we have to see the half of the distance. This is the half of the distance. Half of the diameter means it will be radius. So, we are taking only from here to the nucleus. Okay, that's what it is. 1/2 of the distance between the nuclei of 2 adjacent identical atoms of neighboring. This is neighboring to this one. Okay. In case of monoatomic noble gases, van der Waals radius is taken at the time of closest approach. In the noble gases, whenever the closest approach will be there, that time they will consider the van der Waals radius. Okay. The gases means freedom of molecules will be present. Whenever the approach will be closest, that time they will consider the or recognize the van der Waals radius. Example, van der Waals radius of chlorine is 180 picometer while covalent radius is 99 picometer. Means if you take this distance again, half of this is covalent. We are taking here is van der Waals. Next is ionic radius. It is defined as the distance between the nucleus of an atom at the point to which the nucleus has influence on its electron cloud. Electron cloud means where the nucleus having the effective nuclear charge towards the or end up with the last electron, we will call it as electron cloud. It may be continued with the external or outermost electrons, but the influence where it will stop, that side we will call it as electron cloud. Okay. Example, ionic radius of sodium ion is 95 picometer, ionic radius of chloride ion is 181 picometer. Why? What is this known as? See here, anion is greater than in size than cation. How it has been represented, how it has become like this means, ionic radius of positive ion means that is cation is less than the atomic radius of its neutral atom. Neutral atom means parent atom. The positive ion, that is cation, is smaller than the parent or its neutral atom. How it is become smaller means the positive ion is formed by the removal of the electron, one or more electrons from the valence shell of an atom. Valence shell means outermost shell. Hence, the effective nuclear charge on the remaining electrons increases and the electron cloud shrinks. See here, if this is the nucleus, this is shell. Okay. If this electron is removed, one or more electrons will be removed. Here, protons will be present, right? It will be having the attraction towards the outermost electrons. What will happen? It will attract everything. That time, the overall shell will be shrink getting. Okay. The electrons, the effective nuclear charge will be increases over the electrons and the electron cloud shrinks. That's why the neutral atom will be larger and the cation will be smaller. See here, 11 protons, 11 electrons are present. When electrons are removed, 11 protons, 10 electrons will be happen. The size will be decreased. The same case, ionic radius of a negative ion, that is anion, is larger than the atomic radius of its neutral atom. Why it has become larger? Means because the negative ion is formed by the addition of one or more electrons to the valence shell. Hence, the effective nuclear charge on the electrons decreases and the electron cloud expands. Same concept, here we are removing, but in the anionic species, we will add up to the outermost shell. The electrons will be add up to the outermost shell. That time, effective nuclear charge will be decreased. It cannot have much more electron effective nuclear charge on the adding up of electrons. So what happen? It will expand. What will expand? Whatever the size, ionic size will be there, it will expand. Okay. See here, the neutral atom of chlorine is 99 picometer, but the anion of the chlorine is 181 picometer. Okay. It has been expanded, the electrons cloud. Okay. This is the difference between cation and anion, and how the cation is smaller than the parent atom and how the anion is bigger than the neutral or parent atom. Next is variation of atomic size in the periodic table. First we will see down the group. In down the group, how the variation of the atomic size will be seen. Down the group, what will happen? Automatically atomic number will be increased. If atomic number is keep on increasing, principal shell will be increasing, right? The distance between the nucleus and the outermost electron shell increases, size of atoms increases, correct? This is nucleus. The atomic number keep on increasing means the shell will be keep on increasing. That time what will happen? The distance between the nucleus and the outermost electron will be held less strongly to the nucleus. The electrons will held up with nucleus will be in less attraction or less interaction. Okay. The size of atom will be keep on increasing. By that reason, we can tell the variation of atomic size down the group is increases. Okay. What is the reason? Increase in atomic number. Number of principal shells are increasing. The distance between the outermost electron and the nucleus is more. The attraction force will be less. That's why the atomic radius will be increases. See here, lithium, sodium, potassium, rubidium, cesium. If you see the atomic radius, it is keep on increasing. 152, 186, 231, 244, 262 like that. It is halogen. Same thing we can see here. If you see same thing here in the graph, the x-axis is atomic number, the y-axis is atomic radius in picometer. See, fluorine in halogens I am explaining. Fluorine 72, chlorine 99, bromine 114, iodine 113. It will be keep on increasing. Same thing, lithium, sodium, potassium, rubidium, cesium, 152 to 262, it has been increased. Down the group, atomic size will be increased as the principal shell will be increases. Next, we will see the variation of atomic size in the periodic table with along the period. Okay. Along the period, the atomic radii of the elements decreases from left to right. From left to right, the atomic radius will be decreased. Why means, along the period, the nuclear charge increased by 1 unit, but the additional electron goes to the same principal shell. Okay. Every time the 1 unit or the atomic number will be increased, the electron will be increased. The electron will be added to the same principal shell at the same time. What will happen? Number of protons will be increased, here electrons will be increased. But the electrons are going up and adding to the same principal shell. By the increasing of protons, it will have the tendency to hold that electrons, means attraction towards the electrons. What will happen? It will pull the electrons towards the nucleus and the size of the atomic radius will be decreased. How it will be decreased? Electron cloud will be shrink. Okay. As a result, the electron cloud is pulled closer to the nucleus. by the increased effective nuclear charge. As I told, the protons will be increased, right? That will be pulling towards the electrons near the nucleus. Hence, the atomic size decreases. Okay. See here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is second period along the period we are looking up. All are having two shells. Two principal shells are present. Here, 3 electrons. See the outermost electron. 1 electron is present with 150 picometer. In beryllium, 1 electron is added up with 112 picometers. Gradual changes have been seen. Again, same shell, 1 more electron, decreased in size. See here, keep on adding up the electrons to the same shell at the time and reducing the size. At the end, see how many electrons are present in the outermost shell. See, only electrons only seeing up. That's why the protons or the nucleus are tending towards it. The size will be decreased. From 150 to 71 picometer, it has been reduced. In graph, if we see, near 150 it is there. Now it is reduced to 71 picometer. This is a slightly reduced. Lithium to beryllium, beryllium to boron, next carbon, nitrogen, oxygen, fluorine. According to atomic number we have told. Okay, this is the variation of atomic size down the group and along the period. We'll see next about isoelectronic species. This is very important. You have to know what is isoelectronic species for the examination part. The atoms or ions having the same number of electrons but different magnitude of nuclear charge are called isoelectronic species. Same number of electrons will be present, but magnitude of nuclear charge will be different. Those species or atoms or ions, will call it as isoelectronic species. So, first we will see some of the examples. See, oxygen, fluorine, sodium, magnesium, we are taking up with the example. All are having different atomic number, those we know. Oxygen will be 8, fluorine will be 9, sodium 11, magnesium 12. How it will be having then same electrons? You have read about ionic radius, right? If we are having the anionic charge with the number, how many numbers are there? Those many electrons should be added. If we have the positive charge, how many positive charge are there? Those many electrons should be removed. That time, all the electrons will be getting equalized. We'll see. Oxygen will be having number of electrons will be 10. 2 minus means 2 will be added up. Fluorine F minus means 9 will be atomic number. 1 anionic charge, 1 electron will be added. Again it will become 10. Sodium plus means 1 cationic charge. 11 is the atomic number. 1 will be removed. 1 electron will be removed. Magnesium 2 plus means overall atomic number 12. 2 electronic species will be removed. That time all the elements will be having same number of electrons, that is 10. Okay. This is about the isoelectronic species with the example. Okay. We'll see the variation of ionic size. See here, they have given the variation. What variation? If you are having the large anionic charge, it will be the having greater size. Right? O2 minus, it is already having 8 atomic number. It has been increased for 2. The size will be increased. Again, F minus, this is Na plus, Mg2 plus. Whichever the positive sign will be increasing, that will be less in number. Wherever the anionic species with the large number is getting increased, the larger will be the size. As the nuclear charge increases, the electrons are held more strongly by the nucleus. Hence, the effective charge increases and the ionic radius decreases. That's what I told. Here, the anionic species, whenever it will increase, number of electrons will be increased. Okay. That time, the interaction between the nucleus and electrons will become less, atomic size will be increased. Whenever the cationic species are more, that time electron pull towards the nucleus will be experienced. The electron cloud shrinkage will happen. That time atomic size will be decreased. This is about the isoelectronic species. I hope you have understood the every kind of thing what I have today taught. Okay. In the next class, ionization enthalpy of an element, electron gain enthalpy or electron affinity, electronegativity and periodic trends in chemical properties will be seen. Okay. Next session is also a very important and interesting session. So, please keep on watching and thank you very much.